Microservices. We are living in a world of frequent changing technologies from cloud to Docker and containers and many other things for efficient, managed and reliable solution in less efforts, which can easily be supported by our operation also. In this discussion, we will explore the microservice, how this will be helpful for us in achieving a reliable and efficient solution. Hello my dear friend, my name is Rajiv Dave and we will discuss the evolution of microservices. I am taking an example of online shopping and its different modules. Like you can see here, in online shopping, you generally perform these functions, right? Add to cart, store, offer, delivery, wish list, shop, search, and the payment module, mobile. So I would like to go back to around 20 years back in COBOL world, where we used to write a program in single thread. Actually, I don't want to mention it single thread, but we usually write to program in a single thread. It was really hard to write or remember the changes, right? Because when we write a programs, it becomes a 5,000 or 6,000 lines of code. So it was really hard to remember the changes and debug the changes. Sometimes if we need to make one changes, it disbalances all the code and we struggle to debug. Then we came to know about the modular programmings, or you can say the modular programming came into the existence. So here we are talking about where exactly we are going to write a program in a single thread. So everything in a single container, you can see. So this box I am considering is as a single container where we are writing everything, every functions, add to cart, store, offer, delivery, wish list, shop, payment, mobile, everything on a single thread. Now when the modular programming came into existence, then how exactly it looked like. So this is what exactly we try to write the COBOL programs. You can see the identification division and the environment division, configuration sections, right, and procedural divisions. So we write many different procedures for different functions. Now, what exactly means of modular programmings, or you can say the monolithic programming? Modular programmings can make the code more readable, maintainable, portable, and reliable. How exactly this is possible? So what we did, that we divided the overall container into the small containers, right? So we divided over a container in small modules. So you can see we have written one module that is add to cart, means each and every function related to add to cart is defined into this particular module. In addition, carving up a design into the separate modules make it much easier for individuals on the team to work independently on the separate part of the implementation without getting in each other's way. Now what we can do, that we can assign a one add to cart function to one member, and second we can assign a store to some other, and same like that the offer, delivery and wish list, shop, right? So each and every module we can align to different people, and different people can work on their separate modules, right? So if errors are made during the maintenance, they are limited to the specific module. If suppose I got an error in wish list, so what I can see, okay, I don't need to go to the whole program. I just need to go to the particular module of wish list, and we can change that particular program very easily, and we can debug it very easily. We can find the exact root cause of the error. So that's why the issue is usually easily to track down. I am definitely not trying to prove that COBOL was a bad and right now we are doing everything good. No, this is not a objective of this particular session. COBOL was one of the most popular language, and after COBOL we saw many programming language on which we worked on like FoxPro, Clipper, right? This also became very popular because of its modularity and easy to write, right? So in summary, what exactly we want to say it here? What exactly is the monolithic program? Tightly coupled, highly cohesive code where every part of the code makes assumption about every other part of the code, right? Whereas in modular program, loosely coupled, very separated code where every part of the code communicate with other parts through more or less standardized and neutral interfaces. That architecture, what exactly monolithic architecture means. So basically, in this, the entire software is composed in a single piece that is designed to be self-contained. So what I mean by that, basically all the components of the monolithic program are interconnected and interdependent on other words. If I put it, I will say that it will give you a tightly coupled software where each component along with its associated component must be present in order to execute or compile the code. It means in this particular section, what I mean to say that each and every module should be there to compile the code, right? So there is an interdependency on that particular code, and they are dependent on each other, right? So let's discuss some other point which may be useful for all of us in this section. So we are talking about now this section. So here we can see we have divided each and every modules in a different sections. So you can see here there are various sections where exactly we have divided the module. So you can see the first one may be the store, second one may be the delivery, third one may be the offer, fourth one may be the any other online shopping payments, fifth one may be the wish list. So you can see here the interesting part of this, that each and every module, each and every section is independent of each other. It means that if I found anything, any problem in payment, so we don't need to touch the shopping cart, we don't need to touch any other section, we just need to touch the payment section because we have found the error in payment, right? So here the interesting part will be that if suppose we have so many microservices, so we can say, we will discuss in detail also, we can say that each and every microservice can be written in different languages also. Means what I mean to say that if suppose I have a team of 15 people, but 4 people know the Java, 3 people know the Python, 3 people know the .NET. So we don't need to dependent on each and every programmer that okay, my whole program should be written on Java. But what we can do, that one microservice we can write down in Java, some other microservice we can write down in Python, the third one we can write down in .NET. So here very easily we can define it, or we can write down in different language here. So how exactly it is, so you can see that to cart, offer, delivery, wish list, shop, search, payment and mobile. So here you can see that each and everything is independent of each other. There is no dependency on anyone. So important thing is the design, the technical design of this particular microservice. We cannot say that okay, if we will introduce some technology and it will change it into the microservice. No, we need to design it like this so that it should work independently to each other. So design is the most important portion of the microservices. Now let's discuss about the point by point what exactly we want to say, that how exactly it is important. So let's take first example of deployment. So monolithic app allow you to set your deployment once and then simply adjust this based on ongoing changes. Means what I mean to say here, so deployment means the monolithic app allow you to set your deployment once and then simply adjust this based on the ongoing changes. What we do generally in monolithic app, we just deploy it once, or when we need any changes. So means end-to-end program we deploy. We do not deploy delivery, we do not deploy separately payment, we deploy end-to-end program. At the same time, however, there is only a single point of failure during deployment, and if everything goes wrong, you could break your entire project. It means that what I mean to say here, that if something goes wrong in payment section, then it can break your entire project, entire online shopping project. But again, I am saying that I am not trying to prove here that monolithic is a bad programming design. We will discuss in detail in this upcoming section here, right? Whereas if we use the microservices in place of the monolithic, what is the advantage here? Especially in case of the deployment. So in microservice require much more work. You will need to deploy each microservice independently. You only need to worry about the orchestration of the tools that try to unify the format of your CI/CD pipeline, continuous integration and continuous development. So this is a very important section where exactly we talk about the DevOps or CI/CD to reduce the amount of time required for doing it for each new microservice. So here, especially in case of the microservice, you need to take care that your CI/CD format should work efficiently in case of deployment of the microservices, right? Because we may deploy payment, we may deploy something separate store, we may deploy something separate wish list, right? So our CI/CD pipeline should work very aggressively. If you will break something, then you will break only one module, one is small microservices, which is less problematic than the entire project. If suppose your payment is not working, but at least your other section, other point, other area is working fine overall, right? It also must easier to roll back one small microservice. Now let's talk about the monolithic. If we need to roll back, we need to roll back over all the project. But in case of the microservice, if suppose wish list is not working fine, then we can roll back very easily. Just only we need to roll back the wish list. We don't need to roll back the other modules. Now let's talk about the maintenance. If you plan to use a microservice architecture, you have to introduce the DevOps for your team, because microservice design is something different, because you need a Docker orchestration tool like Kubernetes. So you have to, because may possible that your developer doesn't know anything about the Docker and microservice. So there should be a DevOps team which should be well aware about the DevOps tool, the Docker, Kubernetes, etc. So you have to manage the infrastructure with lot of moving parts, because there may be around 10 to 20 different microservices which you will install in different infrastructure. Someone has to monitor and maintain the functioning state of your continuous integration configuration for each microservice and the whole infrastructure. You have to maintain this particular thing, because in place of the single program, you are now trying to deploy the 10 different modules. So there should be a good monitoring in place so that we can check any problem in any area frequently. Now let's talk about the scalability. For scalability, microservices are again better suited. Monolithic apps are hard to scale because even if you run more workers, every worker will be on a single whole project, an efficient way of using resources. Worse, you may write your code in a way that would render it impossible to scale it horizontally, leaving only vertical scaling possible for your monolithic app. Whereas in microservice, this is much easier. Resources can be used more carefully and allow you to scale only that part that require more resources. Suppose resource management is very easy in this case. Suppose I assume that payment part will take a longer time. So what we can do, we can align more resources to the payment part. Suppose searching part takes some more resources, so we can align more resources to searching part. If wish list takes only less resources, so we can align one person to the wish list only. So it totally depends that how exactly you can scale as per your resources. Now let's talk about the cost. Now cost may be really tricky for this particular solution because monolithic is cheaper in some scenarios. Because with the better scalability of microservice, you could set up an auto scale and only pay for that when the volume of the user really requires more resources, right? So suppose in case of the payment, you need more resources, you can align more resources to the payment if required. But in case of the monolithic, because it's a single point or single program, so it is very hard to imagine, or it is very hard to implement the resources where exactly we need the exact resources. At the same time, to keep the infrastructure up and running, you need to DevOps, you need a DevOps, so you have to pay for it. And with the large monolithic app, you may host a very expensive instance because you cannot share it over the multiple small cheap hosts. In monolithic app, you may need a very expensive instances because you are going to deploy everything in a one single server, or you can go for the load balancer. But in case of the monolithic app, you can see that okay, we have aligned everything in different machines. So it may not require the expensive instances, especially. Now let's talk about development. Now suppose if we have in our project, we have to write down a 10 microservice, and it will be not easy for you to deal it. The best way with microservices is to build your Docker Composer file from the beginning and develop through Docker. Now, I don't know whether you are aware about the Docker or not. We can discuss in detail. But if you will make your Docker from the beginning, so it will be very easy for you in near future to deploy microservice in any instance in a minute. So it helps you to reduce the time spent onboarding new people. Simply run the system from the scratch and launch all the microservice you need. If you need one more instance, suppose in festival season, you need more resources in only some areas, like in payment, like in search. So you can add more resources very easily in that area during festival season, in payment and the search and the shopping. You need not to add resources in wish list, whereas in case of the monolithic app, you have to add resources for all modules. But in case of the microservice, you only need to add resources where exactly you require it. On the other hand, when you developed one microservice, you may have a case in which you don't need to run other part of the application at all. This result in fewer problem, right? Due to the better process of breaking down the task and ability to isolate developers across microservices. Doing code reviews and QA is simple. You can give a payment part to one QA, other parts to other one, third part to other one. So it is very easy to manage even in this case and release because microservices are smaller. So if you have a proper architecture, so you can very easily release a new feature faster by reducing a QA time, build time, test execution time. Monolithic app, if you need to change anything, if you have to change anything, you have to go through from end to end testing. Whereas in case of the microservice, if you have a issue in payment, you can only test the payment section. You don't need to go to the end to end testing, especially in case of microservices, right? So especially one more sections where exactly I would like to talk on this, that is reliability. Microservice, you can see there always a winner here, but please do not think that monolithic is a loser. Breaking one microservice affects only one part and causes issue for the client that use it, but no one else. If we have a 5 different function, one function is not working in case of the microservices, then only one function is not working, but other 4 functions are working fine. Whereas in case of the monolithic, if one function is not working, it means that your overall whole program may have an issue, right? So we need to take it very carefully while choosing in between this. So let's discuss that what exactly is the better for me. Now we are confused that whether we issue the microservices or whether we issue the monolithic app. Use monolithic architecture. As per my understanding, I'm telling you, if you have a small team, a small project, your spending power is less. You cannot afford DevOps. Do not see performance bottleneck for some key functionality. Think that microservices are cool and it is a trend. Please do not go towards the microservice just because of Gartner is saying something or there is something new coming along. Keep in mind that if you find out that there is a need of microservice in your project, monolithic architecture always carries the risk of breakdown as a result of these small microservices. Then when we should use the microservice architecture, I think you must have imagined that what I mean to say here. If you don't have a tight deadline. So if you have a tight deadline, please do not use microservices because microservice need a research and architectural planning before it is going to be executed on the floor. If you have a team of different languages, use microservice. You can align 2 resources to Java, you can align 2 resources to .NET, you can align 3 resources. Otherwise, in case of the monolithic, if you are trying to write a program in Java, then the other resources who do not know the Java may be sitting idle. If you are worried about the scalability and the reliability of the project, then use microservice. As you will have to understand, designing a good microservice architecture does not only require technical skills, but also a very detailed knowledge of business to which it responds. Again, I am repeating this particular because I am going to end this session with this line only. As you will have to understand, designing a good microservice architecture does not only require a technical skill, but also a very detailed knowledge of the business to which it responds. You can always catch me on Twitter, LinkedIn, Instagram, or my personal email ID. I would love your feedback. Thank you so much for watching this. If you have any question, please come back to me. Bye.